Behind a pane of glass in a London museum sits a stub of pink granite about the length of your hand. It is not a statue. It is not a jewel. It is a piece of waste, a plug of stone that whoever made it simply threw away, and running around its surface, cut into rock harder than the blade of a steel knife, are grooves. Even encircling grooves wrapped around the stone like the thread on a screw. This object was pulled out of the ground in Egypt more than 140 years ago. The rock it was cut from is roughly 4,500 years old, and the marks it carries are the reason this video exists. Because to make those grooves, something had to bore a clean cylindrical hole straight down through solid granite, then break out the core left standing in the middle. We have the core, we have the hole. We have thousands of them scattered across Egypt. What we do not have, what no one has ever found, in any tomb, any workshop, any excavation, is the tool that did it. That is the whole mystery in a single object, not a legend, not a carving of a god, a discarded piece of granite that carries the fingerprint of a manufacturing process. And a process leaves a signature the way a hand leaves a print. Read that signature closely, and it describes a machine that cut some of the hardest natural stone on Earth as if it were peeling an apple, and then vanished so completely that after 2 centuries of digging, we have never recovered a single example of it. Today, we are going to read that signature line by line. We are going to look at exactly what the marks say, why the tidy explanation printed in the textbooks does not fully account for them, and why the most important question, what actually cut this stone, and where every one of those tools went, is still open. Stay with me, because the part that unsettles the engineers is not the part the tourists photograph. Most people who visit Egypt never see any of this. They stand in front of the pyramids, they ride a camel, they leave. The few who go inside walk through a bare granite room and never look at the walls closely enough to notice. Most people walk right past the real mystery without ever knowing it is there. Because the strangest thing about ancient Egypt is not the size of the stones. It is the surface of the stones. It is what happens when you put your eye an inch from the granite and see marks that look like they came off a lathe. The man who first noticed was not a mystic or a treasure hunter. He was a surveyor. His name was William Flinders Petrie, and he is often called the father of scientific archaeology. The person who turned Egyptology from grave robbing into measurement. In the early 1880s, he camped at Giza and did something almost no one had bothered to do. He measured everything, not the myths, not the inscriptions, the physical objects, and among the fragments of granite and diorite lying around the pyramids, he picked up pieces that stopped him cold. Cores. Cylinders of stone, the leftover center of a drilled hole, exactly like the plug of rock a modern coring drill leaves behind today. One of them he numbered core number 7. It now carries the museum catalog number UC16036, and it sits in the Petrie Museum in London, tapering slightly from one end to the other, roughly 16 centimeters around at the wide end, and 14 at the narrow. A small thing, and to an engineer, an impossible thing. Here is the first fact that should make you uncomfortable, and it has nothing to do with aliens. Granite from Aswan, the rose-colored granite the Egyptians favored for their most important work, was hauled more than 500 miles down the Nile because nothing closer was good enough. It is one of the hardest stones commonly worked anywhere in the ancient world, somewhere around 6 to 7 on the mineral hardness scale. Copper, the metal the Egyptians of the Old Kingdom actually had, sits at about 3. You cannot cut granite with copper any more than you can cut steel with a stick of chalk. The metal simply smears. And yet the holes are there, the cores are there, cut, drilled, and discarded, at a time when the official toolkit was copper, wood, and stone. That is not a fringe claim. That is the starting point everyone agrees on. The disagreement begins the moment you ask how. And this is where you have to stop thinking of these marks as decoration and start thinking of them as documentation. For a long time, casual observers looked at the rings on a granite core and assumed they were ornamental, or accidental, or just the way old stone weathers. They are none of those things. Not a myth, not a metaphor. Every groove on that core is a record of a tool passing through the rock, one rotation at a time. The stone is a logbook, and when Petrie read the logbook, he did not write down what everyone expected. He wrote down something that made the engineers of his own century go quiet. That is clue number one, and it is the one you can see with your own eyes. Petrie put his instruments on core 7 and recorded 3 features that did not fit the tools he was supposed to be finding. The first was the taper. Both the hole and the core narrow, meaning the cut got tighter as it went deeper, the way a precision ground bit behaves, not the way a loose sand slurry sloshing in a tube behaves. The second was the groove itself. Petrie described a groove that ran around the core in a regular spiral, symmetrical with the axis, and in one place he traced a single continuous groove for 4 full turns without a break. And the third feature is the one that turned his description into a 100-year argument. He measured how fast that groove sank into the stone. The cut descended about 1/10 of an inch for every rotation of the drill. He wrote that the spiral sinks 1 part in 60, a rate of plowing out the quartz and feldspar, in his words, which is astonishing. You need to understand why an engineer finds that number astonishing, because it is easy to miss under the dry language. 1/10 of an inch per revolution means the drill was biting deep into the granite with every single turn, not scratching it, not grinding a dusty film off the top, but cutting it fast, the way a modern machine cuts soft metal. One engineer who spent years on this artifact, Christopher Dunn, compared that feed rate to modern diamond drills and found the ancient cut was hundreds of times more aggressive per turn than what a diamond-tipped industrial drill achieves. Sit with that. A tool from 4,500 years ago, using no diamond as far as anyone can prove, apparently plunging into granite faster per rotation than the diamond machines in a workshop today. And Petrie noticed one more thing, the detail that quietly demolishes the easy answer. Granite is not one material. It is a mixture, mostly of quartz, which is hard, and feldspar, which is softer. If you cut granite with loose sand, the sand wears down the soft feldspar faster and leaves the hard quartz standing slightly proud, because loose grains take the path of least resistance. Petrie measured the opposite. On core 7, the grooves are as deep in the quartz as in the feldspar. Deeper, even. Something was plowing through the hardest crystal in the rock as easily as through the soft, cutting a fixed line regardless of what it hit. That is not the behavior of loose sand. That is the behavior of a fixed cutting point, harder than quartz, driven with real force. Petrie said as much. He concluded, the Egyptians must have had cutting jewels set into their drills, fixed points harder than quartz. He found the same signature elsewhere, in hieroglyphs plowed through diorite, in lines only 1/150th of an inch wide, edges torn rather than scraped, the mark of a hard point dragged through stone under pressure. He was not guessing, he was recording. If a discarded chip of granite, carrying the signature of a machine we cannot identify, is the kind of thing that keeps you up at night, subscribe and turn on the bell. Because the next 2 clues are where this stops being one strange object and becomes an entire industry we cannot account for. Because here is the thing about core 7. It is not alone. That is clue number 2, and it changes the scale of the problem entirely. If there were one strange core, you could call it a fluke, a one-off, a lucky accident by a gifted craftsman. But the drilled holes are everywhere. Petrie found cores and drill holes across Giza. At the Temple of Karnak, there is a granite block with a hole roughly 8 inches across, bored straight into it. Large cores have turned up at multiple sites. The great granite sarcophagus in the king's chamber of the Great Pyramid was hollowed out of a single block and its inner corners carry the marks of drilling and sawing on a scale that dwarfs core 7. This was not a novelty. This was production. Somebody was tube drilling granite routinely as a standard industrial technique across the country for centuries. And the tube drilling is real. This is important because it keeps the story honest. Some of the ancient drill holes still contain traces of the tool. Weathered residue of copper or bronze has been found packed into the walls of old core holes, along with rock tailings and abrasive. So, we know for certain that the Egyptians were pushing metal tubes into stone. The method existed. What is missing is not the evidence that they drilled. What is missing is any surviving example of the drill itself, and any surviving record of how they made it cut so aggressively. We have the holes, we have the cores, we have flakes of the metal left inside. We do not have one intact drill bit, one machine, one instruction, one wall painting that shows the process working on granite rather than soft stone. An entire manufacturing capability spread over an empire, over generations, and the hardware has simply evaporated. Think about what that means for a moment. The Serapeum at Saqqara holds enormous stone boxes, some estimated at 70 tons or more, cut and hollowed and polished with a precision that engineers still find hard to reconcile with copper tools. These boxes exist. You can stand next to them. They are undeniable, physical, finished products. And yet the workshop that produced them, the tooling, the jigs, the drills that bit granite at 1/10 of an inch a turn, none of it has ever been recovered. We are surrounded by the output of a process, and we have almost nothing of the process. It is as if a factory ran for 300 years and then someone removed every tool in the building and left only the products behind. That is the second clue. Now for the third, and it is the one that turns the whole thing over. Because the third clue is not something they left in the stone. It is something modern people tried to do and could not quite finish. For most of the 20th century, the argument about how the Egyptians cut granite was fought on paper. Two camps. Petrie, who said fixed jewel points and hard-cutting tools, and the chemist Alfred Lucas, who said no, it was simpler than that. Loose, wet quartz sand dragged around under a plain copper tube, the sand doing the cutting while the copper just held it in place and carried it deeper. Both men looked at the very same rings on the very same cores and read them in opposite ways. And for decades, it stayed theoretical, because nobody had actually gone out and tried it at full scale on real Aswan granite. Then, in the 1990s, someone did. An experimental archaeologist named Dinas Stocks, trained as a mechanical engineer, decided to stop arguing and start cutting. He reconstructed the tools from the archaeological and pictorial evidence, more than 200 of them, and he took copper tubes and dry sand to the Aswan quarries, the same quarries the ancient stone came from, and he drilled, and it worked. The copper tube spun with a bow, feeding dry sand under its rim, ground its way into granite. The metal did not cut. The sand did, because quartz sand is hard enough to abrade the feldspar and quartz of the granite, while the soft copper tube merely carried the abrasive and wore away with it. Stocks proved the mainstream position was physically possible. You do not need a lost machine. You need copper, sand, patience, and a great deal of labor. And that should have closed the case, but it did not, and this is the part that matters. Because proving something is possible is not the same as reproducing the specific marks on core 7. Stocks himself found the process was brutally slow. Granite came away at a fraction of the rate of softer stone, roughly 10 times slower than alabaster. The cutting crawled. It took enormous effort, thousands upon thousands of rotations, to make a shallow cut. Nothing anyone has replicated with copper and sand comes anywhere near the 1/10 of an inch per turn feed rate Petri measured on the ancient core. And an earlier set of laboratory experiments, back in the 1980s, ran into a stranger wall. When researchers cored granite with copper tubes and loose quartz sand, They often did not get the neat concentric striations at all. Clean rings showed up reliably when they used harder abrasives, corundum, emery, even diamond, not the plain quartz sand the standard story relies on. The experiments confirmed the method could cut granite. They did not cleanly confirm it could leave that signature at that speed. The output was possible. The fingerprint was not fully reproduced. So here is where the story takes on the texture of every great unsolved mystery. The single artifact that started the whole argument, core number 7, sits in a glass case in London and has, in a sense, been quietly walled off from the debate. It is displayed but effectively out of reach for the kind of close, systematic examination that could settle things. Researchers who have wanted to study the full length of that continuous groove, to photograph the entire surface and see whether it truly runs as one unbroken spiral, have pointed out something remarkable. In over a century, no one has ever published a complete photographic panorama of the surface of core 7. Not Petrie. Not anyone since. The most famous, most argued over drilled core on Earth, the object that launched the entire question. And there is no full visual record of the very feature everyone is fighting about. The evidence is behind glass, and the case, in a way, has been closed by declaration rather than by resolution. It was found, it was measured, it was argued over. And then it was left exactly as it was, its most important surface still not fully documented, decade after decade after decade. Now, does any of this prove the wild version of the story? That Egypt had electric machines, lost power tools, technology handed down from some vanished super civilization? No. Let me be straight with you, because the truth here is more interesting than the fantasy. The mainstream explanation has real weight, and it deserves a fair hearing. Denny Stocks did cut granite with copper and sand, in the real quarry, with his own hands, and that is not nothing. It is a serious, replicated result. When a stonemason named Harry Brownlee and an acoustics engineer named John Reed physically examined core 7, they reported that the grooves were not one continuous spiral at all, but a series of individual rings, the same kind of rings you find on ordinary cores in any modern quarry, which would undercut Petrie's most dramatic claim, the unbroken 4-turn spiral, right at its foundation. And the boldest idea of all, that the marks come from some high-frequency machine tool, remains an idea with no surviving machine, no wiring, no factory, no debris, nothing but an inference drawn from the stone. Strip the speculation away honestly, and the machine hypothesis is unproven. That is the fair skeptical position, and it is a strong one. But here is what the grounded skeptical view still cannot make ordinary. Strip away every wild theory, keep only the plain facts everyone agrees on, and what is left is arguably stranger than the fantasy. A civilization working almost entirely with copper, wood, and stone, drilling cylindrical holes through one of the hardest stones on Earth, not once, but routinely at a national scale, for centuries. Cores and holes scattered across Giza, Karnak, Saqqara, the king's chamber. A feed rate recorded by the most careful surveyor of his age that modern experimenters, with full knowledge of the method and modern muscle and modern abrasives, have struggled for years to even approach. A signature that the standard loose sand explanation does not cleanly reproduce in the laboratory, and an absence at the center of all of it. Not one drill, not one bit, not one tool. The single largest body of physical evidence for hard stone machining in the ancient world, and the machinery that made it, is missing without a trace. You do not need to invent anything to be unsettled by that. You just have to look at what is actually there and refuse to look away. And if even the modest version of this is true, it says something uncomfortable about the story we tell ourselves. It means a society we quietly file under primitive, 4,500 years ago, had a mastery of abrasives, of rotational tooling, of hard stone cutting, that we are only now, with instruments and engineering degrees, able to measure, and still cannot fully match with our own hands. It means the tidy line we draw between the ancient and the advanced is not a line at all. It is a smudge. It means the products of a lost workshop have been sitting in plain sight in museums and temples for 2 centuries. And we have spent most of that time arguing about the marks instead of admitting we cannot yet make them. Think about what better tools might reveal next. High-resolution scanning, 3-dimensional surface mapping, the kind of microscopic analysis that can read a tool mark the way a detective reads a bullet. All of that is finally being turned on these cores and holes. We are close to being able to reconstruct the exact geometry of the tool that made Core 7 from the scars it left behind, to calculate its shape, its pressure, its speed, without ever finding the tool itself. And if that analysis confirms what Petrie saw, a cut too fast, too deep, too indifferent to the hardness of the crystal, then the question stops being whether the mainstream story is complete. The question becomes what, exactly, we are still missing about the people who left this behind. Here is the one question that will not let go. If a civilization could cut and drill granite this well, at this scale, for this long, how is it possible that not one of the tools survived when thousands of the holes did? Tools get lost, worn out, melted down, reused. But all of them, every single one, across an empire, across centuries, while the fragile granite cores they discarded as trash sat untouched in the sand for 4,500 years. You do not lose an entire technology by accident and keep only the waste. Either the tools were so precious they were never, ever thrown away, gathered up, and kept out of sight, or they were made of something, or made in a way that we have simply not recognized when we dug it up. Both answers are strange. And whichever one is true, the marks are still there, in the stone, in the glass case in London, waiting. So what actually cut the granite of ancient Egypt? Not a god, not a legend, something physical, something turned by human hands, something that bit into the hardest crystal in the rock and did not care, and then disappeared so thoroughly that after 200 years of the most intense archaeology on the planet, we hold the product and not the tool. The core is still behind glass. The groove is still uncounted. The full surface has still never been photographed. And somewhere under the sand, or melted into some later object, or sitting unrecognized in a drawer in a museum basement, is the answer to a question the stone has been asking patiently, without interruption, since before the first word of history was written. It was cut, it was measured, it was set aside, and the thing that made it has never been found. If this is the kind of buried history that keeps you up at night, keep watching the next investigation, because the marks left in stone at another site point somewhere none of the experts expected.